Hi there, hello, welcome to CERP TV and welcome to our calculus class. If you are new to this channel, please do well to press the subscribe button, and when you do, make sure you do not forget to click on the notification bell so that way you get to know whenever we are dropping a new video. Now you are welcome again. We have some problems to solve. In my recent videos, I've been trying to explain in the very simplest, simple manner, the outside-inside rule. That is a modified version, a much more simplified version of the chain rule. Now we have some problems here, about 5 in number, to help us understand this concept of the outside-inside rule. Now come with me to the board. Let's solve. Now we have number 1, and number 1 says we should differentiate with respect to x. Then we have 2x plus 1 raised to the power minus 3. Now the very first thing I am going to do when I have such a problem is to recognize this is the inside and that is the outside. Generally, whenever you are differentiating a function with respect to x, we have u to the power n, where u is a function of x, a differentiable function. Now this is simply going to be equal to, you carry this power and bring down nu. You repeat u again without touching anything, then subtract 1 from the power, that is n minus 1, then you multiply by the u by the x. Now this is what we call the outside-inside rule. Now how do we apply it here to this problem? Now when you come to that problem, you see that it simply becomes equal to, the derivative simply becomes equal to, you bring down minus 3, you bring it down, which is n. So you have negative 3, then you repeat this inside, which is our u, the inside here is u, so we have 2x plus 1, all raised to the power n minus 1, which is going to give me 3 minus 1, minus 3 minus 1, and minus 3 minus 1 simply gives us minus 4. Then all this is multiplied by the derivative with respect to x of this now, of 2x plus 1. So that's the end of the problem, and this simply becomes equal to negative 3, and then we have into 2x plus 1 raised to the power negative 4. Now when I differentiate 2x, I simply get 2 because the derivative of 1 equals to 0. Now look here, 2 multiplied by negative 3 will simply give me negative 6, then into 2x plus 1 all raised to the power negative 4. So that's the derivative of that problem. So always have in mind this rule. If this is u, a function of x, a differentiable function of x, the only thing you need to do to differentiate it, take your power, bring it down, repeat your u again, and then take n minus 1. And when you have done that, you simply multiply by the u by the x. That's you differentiate the u part. Now the second problem will even explain more to us. And that second problem simply says we should differentiate, we have d by dx, we have 5x cubed minus x to the power 4, all raised to the power 7. So this is simply going to be equal to, I'll take this 7 and bring down. So I have 7, then I'm repeating this without touching anything. 5x cubed minus x to the power 4. Then 7 minus 1 simply gives me 6. Then all this is multiplied by the derivative of this. I'm now multiplying by the derivative with respect to x of this now, which is 5x cubed minus x to the power 4. And this simply becomes equal to 7 into 5x cubed minus x to the power 4. Now we come to differentiate. Now when I differentiate 5x cubed, 3 times 5 will give me 15x, 3 minus 1 is 2, minus, if I differentiate x to the power 4, 4 comes down, we subtract 1, we simply have 4x cubed. Is that okay? So that becomes the solution to that problem. So you see how the outside inside rule is working. The chain rule, which is a modified version of the chain rule. All you need to do, take your power, bring it down, repeat this, minus 1, and then you differentiate this. That's all. And then we come over to look at number 3. And what does number 3 ask us to do? Number 3 simply says you should differentiate, you should evaluate d by dx of 1 all over 3x minus 2. Okay, beautiful. Now notice something, that we cannot see the power here easily. So, but you can see that this is the same thing like differentiating with respect to x. I have 3x minus 2 now raised to the power minus 1. This and this are the same because 1 over a is equal to a to the minus 1. Is that okay? So now that we are seeing the power clearly, we can differentiate. We take this power and break it down. So this simply becomes equal to negative 1. Then I'm repeating that again, 3x minus 2. And then I'm going to subtract 1 from my power. When I subtract 1, negative 1, negative 1, minus 1 will simply give me minus 2. Then multiplied by the derivative with respect to x of the whole of this, 3x minus 2. And at the end of the day, this simply gives me negative 1 into 3x minus 2, all raised to the power minus 2. When I differentiate 3x minus 2, you differentiate 3x, you simply get 3. Now multiplied by 3. Because when you differentiate negative 2 being a constant, you simply get 0. Is that okay? So that's that. This 3 multiplies minus 1 to simply give me negative 3 into 3x minus 2, all raised to the power minus 2. So that becomes the answer to that problem. So you see how the outside-inside rule helps us to simplify differentiation and makes it easier, especially when it has to do with the function of a function. Now we look at the fourth one. Maybe I do the fourth one and then I'll leave this last one for you to do, and then drop your answers in the comment section below. Now we simply have to differentiate with respect to x, and then we have x squared plus 1 all raised to the power 3. Now how can I do this? The same principle applies. Bring down your power, repeat what is the inside, subtract 1 and then differentiate the inside. So this simply becomes equal to, when I carry this 3 and bring down, you have that. Is that okay? And now you repeat this again, you have x squared plus 1. Then we are going to remove 1 here. 3 minus 1 simply gives me 2. So I have 2 here. Now multiplied by the derivative with respect to x of this inside portion of x squared plus 1. And at the end of the day, this simply gives me 3 into x squared plus 1 all squared. Now when I differentiate x squared plus 1, I'll simply have, now when you differentiate x squared, you get 2x. 2x, you bring down this power and subtract 1. So we have 2x. Then when you differentiate 1, of course, you get 0. So at the end of the day, this 3 will multiply this 2. And when 3 multiplies 2, we simply get 6. So I have 6, then this is the x here. I have x into x, then we are now writing this out. X squared plus 1, all raised to the power 2. So you can try this very last one and let me know what came out to be your answer. Thank you so much for coming around. Please, just in case you have not subscribed to CERP TV, you can do that right now, no delays. Thank you and do have a wonderful time. Bye-bye.